And this is the Particles Homework Booklet question 34. We're told that the diagram shows the lowest three energy levels of a hydrogen atom, and we're given those energy in electron volts. We're told an electron is instant on a hydrogen atom, and as a result an electron in the ground state, remember ground state is the lowest possible state, n equals 1, of the hydrogen is excited up to n equals 2. The atom then emits a photon of a characteristic frequency, and explain why the electron in the ground state becomes excited to the n equals 2 level. So it's got to absorb energy from that instant electron, or the instant electron loses energy. Instant just means coming in, just like an incident ray when we're talking about refraction or reflection. And it will absorb the exact amount of energy. Not really sure that's made clear, but you've got to say this bit in the question. But we've got to have the exact amount of energy that matches that energy gap between n equals 1 and n equals 2 will be absorbed. And if we look at that, that's going to be 13.6 take 3.41, so 10.19 electron volts of energy. We're asked to calculate the frequency of the energy. So we're essentially using the fact that the energy gap must be HF. So work out the energy gap, which was the 10.19 electron volts I was talking about, multiply it by 1.6 times 10 to the minus 19 because we need to be in joules. So there's the energy in joules. Then I can just use that F is E over H equals HF rearranged, and I can get myself using H from the data sheet to 2.46 times 10 to the 15 Hertz. The initial kinetic energy of the instant electron is that 1.70 times 10 to the 18 joules, and so we've got to calculate its kinetic energy after the collision. Well, it's going to be the difference between the two. So it came in with that much energy, and we worked out in the previous part that the energy that is transferred to the atomic electron, the electron in the hydrogen atom, is that much. That was equal to the energy gap between the two relevant energy levels. So that's the energy the instant electron started with. That's the energy that's passed to the other electron, and so what's left must be the difference between them, which is 7 times 10 to the minus 20 joules, and that will be left as kinetic energy in that instant electron. Now we've got to show that the instant electron cannot excite the electron in the ground state to the n equals 3. So the first thing we'd have to do is to work out how much energy was required to do that. So that would be going from minus 13.6 up to minus 1.51. And so any difference final, take away initial, well, minus 1.51 minus the 13.6 gives me 12.09. Get that into joules so I can make the comparison with the energy of the incoming electron, and it's 1.9 times 10 to the minus 18. That isn't as much, sorry, that is more than the 1.7 times 10 to the minus 18 that the instant electron has got, therefore it can't happen. I've got that much energy. To do the transition up to n equals 3, I'd need that much energy. Can't happen. When electrons then in the ground state are excited to n equals 3, photons of more than one frequency are subsequently released. First of all, we've got to explain why different frequencies are possible. So if I go back to the original diagram, if I put an electron in n equals 3, a number of things can happen. It can drop all the way to n equals 1, it can drop down to n equals 2, and then drop down to n equals 1. Each of those transitions from 3 to 2, from 2 to 1, to 1 to 3 has got a specific energy associated, therefore will give you a photon of a specific energy, therefore a photon of a specific frequency. So electrons can return to the lower energy levels by different routes in a series of steps is why we can get those different frequencies. State and explain how many possible frequencies could be produced. So as often is the case, I actually do my explanation and therefore the state. So as I just showed you a moment ago, we've got transitions from 3 to 1, from 3 to 2, and from 2 to 1, so that's 3 possible transitions. and the explanation is by listing out what those possible transitions are. So that's the Particles Homework Booklet question 34.